All right, welcome back, everyone. Today we're tackling an absolute staple of modern web development, the JavaScript LoadMore feature. But look, we're not just going to passively scroll through a wall of code today. Instead, we're going to build a mental assembly line together, piece by piece, so you can lock this exact coding pattern into your memory forever. Whether you're building a social feed, a product list, or a comment section, you absolutely need this tool in your toolkit. By chunking the raw code into specific structural pillars, we're basically tricking your brain into lowering its cognitive load. We're taking what looks like a super complex wall of text and turning it into a logical, step-by-step process that is actually incredibly easy to memorize. So, are you ready? Let's get into it.
Okay, let's dive into this. Here is our roadmap for today's explainer. First, hooking the DOM elements. Second, setting state variables. Third, building the async framework. Fourth, rendering to screen. And finally, tying it all together.
All right, step number 1, hooking the DOM elements.
This is literally the very first station on our mental assembly line. It's where we gather our raw materials. Because, before we can write any dynamic, flashy logic, we absolutely must grab the physical objects on our web page. Think of DOM selection as creating literal hooks. You use them to grab specific HTML elements. Without these hooks, your JavaScript code is just kind of floating out there in the void with absolutely nothing to target, update, or control.
So let's look at the exact code for this. We have const todoList equals document.getElementById todoList, and right below it, const loadMoreBtn equals document.getElementById loadMoreBtn. These two constants are our literal hooks into the HTML document. We are explicitly telling the browser, hey, go find that specific list container and that specific button and lock them into these JavaScript variables right now so I have a direct pipeline to them at all times.
It's really crucial to understand the contrast between these two hooks. Think about it. One is our to-do list, which is our list container. It's totally passive. It's just sitting there on the page, waiting to hold whatever fetch data we throw at it. But the other one, loadMoreBtn, the action trigger, that element is highly active. It's the actual mechanism that gives your user the literal power to reach out and fetch more data.
Moving right along to pillar number 2, setting state variables.
An assembly line just cannot function without memory to track its mathematical progress, right? Well, in development, we call this state management. Think of state as your application's short-term brain. It's just a collection of variables that keep track of the current data, our absolute data limits, and our progress across multiple, totally independent user actions. Every time a user clicks that Load More button, the brain needs to know exactly where it left off, so it doesn't just fetch the exact same items all over again.
And here's what that short-term brain looks like in code. We set const limit equals 50, then let skip equals 0, and let totalTodos equals 0. Now what's really fascinating here is the absolute crucial contrast between the static, unchanging const and those dynamic shifting let variables. We use const for the limit because, well, our batch size of 50 items per click is never going to change. It's locked in. However, skip and totalTodos will constantly update and grow as we pull in more data. And that is exactly why they must be declared with let, to allow them to mutate.
Okay, let's pause for a super quick memorization checklist. We've got our DOM hooks established, that's the list and the button, and we've got our state variables initialized, limit, skip, and totalTodos. Cement these two initial memory chunks into your mind right now, because once you have your hooks in your state, you are fully prepared to build the actual engine of this assembly line. Which brings us to step 3, building the async framework.
It's time to construct the asynchronous engine shell. This is the piece that will confidently fetch our data from a server behind the scenes. And to build a reliable engine, we need a try/catch block. This is literally the ultimate safety net structure for modern asynchronous code. It attempts an execution, which is the try part, and gracefully handles any errors, which is the catch part. Honestly, you should never attempt to fetch data across the unpredictable internet without this safety net in place.
Let's trace the literal skeleton for this engine. We start with async function fetchTodos. Open the bracket, try. Open the next bracket, loadMoreBtn disabled equals true, and loadMoreBtn textContent equals loading. Notice how we immediately protect the user experience here? The very first action we take inside our try block is to disable the button and alter its text to loading. This completely prevents the user from aggressively mashing the button 10 times in a row while the network is busy thinking. And this brilliantly illustrates how the bottom half of that framework functions. We close the try block and write jcatch error console.error error loadMoreBtn todos.textContent equals error. This right here is the safety net catching our fall. If the user's internet suddenly cuts out, or if the database server crashes, the catch block grabs the error, logs it out for us developers to inspect, and safely updates the button text to error. The UI handles the failure cleanly, and the user isn't just left staring at a frozen screen forever wondering what went wrong.
All right, pillar number 4, rendering to screen.
This is the display panel of our assembly line. It's where we take raw data and physically manufacture it into visual elements. But before we get into the exact syntax, let's just map out the inner loop logic sequentially so you understand the flow. Step 1, we loop through the array of data we received. Step 2, for every single item in that array, we create an LI, or list element. Step 3, we set the text content to make it readable, adding emojis based on the data status. And step 4, we append that beautifully finished element right onto our main list.
So here is how that translates directly into JavaScript. We write function renderTodos, open bracket, todos.forEach, todo to this, const li equals document.createElementList. See what's happening there? We are receiving an array called todos, and as we iterate over it item by item with the forEach method, we are actively commanding the browser to generate a brand new, completely empty list item for every single piece of data in that array. Next, we've got to fill that empty list item with our actual data. We write li.textContent equals backtick, $curly brace, todo.id, $curly brace, todo.completed, question mark, ch, ack, slash, exclamation point, underscore x, $curly brace, todo, and close the backtick. This single template little line is incredibly powerful. It seamlessly strings together the data's ID number, the actual text of the to-do item, and then it uses an inline ternary operator to instantly decide between a green check mark or a red X emoji purely based on the true or false completion status of that specific item. It's a real game changer for writing clean code.
And finally, we close out the rendering loop. todoList.appendChild li, curly bracket. This appendChild method, it's the final heavy lifter on our assembly line. It grabs our newly built, perfectly formatted list item and physically attaches it to the todoList DOM hook container. Yep, the exact same passive container we set up all the way back in step 1.
Now for the grand finale, step 5, tying it all together.
We have our raw materials, our state memory, our engine, and our renderer. Now, it's time to flip the switch. Look closely at this final snippet of code. We have loadMoreBtn.addEventListener click fetchTodos, and right below it, an isolated fetchTodos. So the absolutely crucial point here is that we actually have 2 distinct triggers working in tandem. The event listener stands guard indefinitely, just waiting for the user to physically click the button to load more items. But that standalone fetchTodos call at the very bottom, that's our initial spark. It automatically triggers the first load of data the exact millisecond the script runs, which guarantees the user doesn't just load into a totally blank screen.
And just like that, our mental assembly line is fully operational. Let's aggressively review our final assembly checklist. 1. Grab the hooks. 2. Set the state variables. 3. Build the async engine framework. 4. Render the visuals inside a loop. And 5. Flip the switch with your event listeners. By deliberately chunking the script into these 5 solid pillars, we completely bypassed that overwhelming wall of code. Instead, we created a highly structured, logical sequence that your brain can easily retain and recall on demand.
So I want to leave you with a provocative challenge today. Can you rewrite the JavaScript LoadMore feature from memory right now? I seriously challenge you to do this. Don't look at the source material, open up a blank file in your code editor the absolute second this explainer ends, and see how much of this mental assembly line you can build entirely on your own using just our 5 pillars. I guarantee you have the tools to do it now. Keep pushing yourself, keep building, and I will see you in the next explainer.